Okay, so for the online people, hope my voice is very clear for you. Can you please confirm your chat once? Console. Right heading as Kubernetes. So what we are going to discuss now? Kubernetes, right? Okay. Okay, so before starting the session, you have seen Docker, right? What is the purpose of using Docker, sir? Sorry? You have? What is the purpose of using Docker? What it is? Use it to create containers, correct? Okay. Sir, but why Kubernetes? Docker is used to create containers. Okay, I'll accept that one. But why we need to use Kubernetes? What is the purpose of using Kubernetes? It is also used to create containers. Okay. But wrong. First of all, Kubernetes never going to create containers. Kubernetes is used to orchestrate the containers. What it will do, sir? Orchestrate. Actually, to orchestrate containers, we have seen Docker Swarm, correct or not? Docker Swarm main purpose is to orchestrate. Sir, you have seen how to use Docker Swarm and you have done one practical, you have done one real-time project as well. Is it orchestration good or not, sir? But why we need to learn Kubernetes? In Docker Swarm, we have some limitations. What we have, sir? Due to that limitations in Docker Swarm, we are going to use Kubernetes. What we are going to use? Pronounce this one perfectly for me. How to pronounce this one? Kubernetes. Sure. Kubernetes. Sure. Is it Kubernetes or Kubernetes? Q. Okay. So then? Okay. So what we are going to call its exact name is Kubernetes. Someone will call it as Kubernetes, not our side, like it's from English accent. But if we are like here accent is exact pronunciation is Kubernetes. What we are going to call it as? Shortcut for Kubernetes is K8s. Okay, K8s we are going to call it as. What we are going to call it as? Sir, why we need to call them as K8s means first letter is K. Last letter is S. In between, how many words are there, sir? 8 letters. How many letters? So that is the reason why we are going to call it as K8s. What we are going to call it as? The concept clear? If you see the logo of Kubernetes, you will find something. What is the logo, sir, here? Wheel? Wheel or ship or octopus? Wheel, which wheel? Wheel, what we call this one? Wheel, we have something called as soap detergent, right? Is it that or what? Gear. Steering of which steering? This one. Wheel, we have something called as soap detergent, right? Is it that or what? Gear. Steering of which steering? Ship. Okay. So normally we will deal with containers, correct? If we talk about containers, in real time, normally if we talk about ships, ships are going to load the containers, correct or not? Containers are going to place on ship. To control that ship, we need to have the steering or not. Same like containers we are going to place. To control the containers, we need to have Kubernetes. What we need to have? Kubernetes is originated from the Greek word. Which word? That is called as salesman. What is the meaning of Kubernetes in Greek? Salesman means the person who drive the ship actually. Their person will drive containers. Here we are going to manage containers. Is it clear? Docker is the tool used to create containers, but to manage the containers, to orchestrate the containers, and to distribute the containers, we need to have Kubernetes. What we need to have, sir? Kubernetes originated from which word? Greek word. What is the meaning of Kubernetes in Greek? Salesman. Salesman means the person who drive the ship. Okay, that's it. On mute. Okay, sorry. I haven't explained till now anything. I'm just telling about Kubernetes. Sir, what is the purpose of using Kubernetes, sir? Docker will create containers. Docker will create that containers we can manage with Docker Swarm. But why we are not using Docker Swarm is Docker Swarm have some limitations. What we will have on Docker Swarm? First of all, container auto scaling is not possible. Automatically we cannot scale containers. Manually we need to scale. I have shown you how to scale containers, replicas. That is manually, but automatically we cannot do it. And load balancing we cannot do on containers. Auto scaling is not possible. Load balancing is not possible. And priority of the pods, eviction of the pods are also not possible. Like we have some limitations. I'll tell limitations later point of time. Okay. Kubernetes originated from which word, sir? Greek word. Which word? In Greek, what is the meaning of Kubernetes? Salesman means pilot of the ship actually. Pilot means there, we're plane actually. But here we are going to call it Hailman. Sir, Kubernetes shortcut is also called as K8s. What we are going to call it as? What is the meaning of K8s? K for Kubernetes, K for like starting letter, S for ending letter. In between how many letters you are having? That is called as Kubernetes. So of course you can call it as K8s, Kubernetes, like that. And second thing is, sir, Docker is used to create the containers. Docker is used to create the, of course it can also run containers, manage containers, but instead of Docker Swarm, we are using Kubernetes for better purpose, advancement. Why we are using? Advancement. So let's talk about Kubernetes now. So basically Kubernetes is an open source container orchestration platform. Container orchestrate means it will manage the containers, but it won't create the containers. Container will create by Docker, and that container is going to manage by Kubernetes. It is an open source. What is the meaning of open source? Anyone can use it like that. It is used to automate many of the manual processes like deploying, managing, and scaling containers. I said right. So in Docker, we need to deploy manually, but Kubernetes we can deploy automate. Of course, Docker also you can deploy automation, and you can manage the containers and you can scale the containers. Everything we are going to do in automationally by using which tool? Kubernetes. Docker Swarm is some manual work. Kubernetes completely automation work. Kubernetes was developed by whom, sir? Google, and they use Go language. Both Docker and Kubernetes written on Go programming language. Which language? Go programming. What is the meaning of Go programming? Go language is Google official language. Which language? So later, but sir, initially it was created by Google. Why? Because Google will have some hundreds of applications. Google Drive, Google Photos, Google Maps, Google Classroom, Google Sheets, Google Docs. Hundreds of applications will be there for Google. Google Music as well. To manage the hundreds of applications, they developed an internal system called Borg. Initial name is Borg actually. What is initial name? Borg, and that Borg was renamed as Kubernetes. It came in the market on which year? But Google donated that to CNCF. CNCF means Cloud Native Computing Foundation, right? CNCF means Cloud Native Computing Foundation. Sir, Kubernetes is initially launched by Google, but who is maintaining the Kubernetes, sir? CNCF. What is CNCF here? Cloud Native Computing Foundation. What is the meaning of Cloud Native Computing Foundation? See, Cloud Native Computation Foundation is nothing but, for example, I have cloud. These people are going to develop the service of the cloud. For example, I have one service. They can develop the service. That is called a CNCF. Cloud Native Computing Foundation. What we are going to call it as? What they will do, they will develop the existing features of the cloud services. Like that. Sir, initial version of Kubernetes came to market on which year, sir? Basically, it came on 2014, but initial version came on year 2015. Okay. Sir, we are having Docker Swarm. But why we need to use Kubernetes means containers are good and easy to handle and bundle your applications. In production environment, you need to manage the containers and run the application to ensure no downtime. What is the meaning of downtime? Right, downtime means amount of time when your application is unavailable. Downtime means what? Amount of time your application is unavailable. So containers are easy to manage. In container, we can run our application. And in last class, I have shown if I delete one container within the next second container created or not, sir. The moment when you stop one container, second container is creating. That means there we have zero downtime or not. We don't have any time log. But even though, sir, we have zero downtime in Docker Swarm, we have some limitations. In Docker, we use Docker Swarm for this. But anyway, Docker Swarm has drawbacks. What we are having, sir? Due to the drawbacks, we came to Kubernetes. We can do it from Docker Swarm as well. But why we are not preferring Docker Swarm means it has some limitations. What we are having? Due to that limitations, we are coming to the Kubernetes. Sir, when we are talking about Kubernetes, first thing you need to know about the architecture. Sir, Docker architecture is very, very easy. Docker architecture is very, very. If you see the Kubernetes architecture, how it is, sir? Clumsy. Are you able to understand this one? Then how we can proceed with the class? Just see it for 1 minute, and tell me what you are able to understand. Observe for 1 minute, I'll give 1 minute of time and let me know what you have observed on this. Are you able to get something here by using this diagram? Master and node. Okay, first point. Second point. APIs use chestunara. Okay. Then some man is there. This man is connecting with API server. API server is connected to control manager and scheduler. And again, API server is getting response from kubeplate, kubeproxy, CA advisor. Like what these are, first of all? We are not able to find it, right? Remember, understanding the Kubernetes architecture is very, very difficult. That is not that much easy. So Kubernetes architecture is a difficult architecture. You know, You have seen Git architecture, only 3 steps. Jenkins, master and slave, 2 steps. Ansible architecture, master and worker node. Docker architecture, client, daemon, registry. Everything is easy or not, sir? But here, if we see, these are having this much of things. But if you try to understand, it will be very difficult. I'll not ask you to understand. I'll ask you to memorize it. Understanding is different, memorizing is different. What you are going to do now? Memorizing. First of all, try to memorize. If you try to memorize the things, you will get to understand easily. Okay. So now go here, sir. For example, what I will do is, I have the cluster. Inside cluster, I have the nodes. Inside nodes, I have the pods. Inside pod, I have the containers. Inside container, I have the application. See. First of all, I have the cluster. What I will have, sir? Cluster. Cluster means combination of nodes. Am I having master node and worker node, sir? Is it a cluster or not? Inside cluster, what I have? Nodes. Master node, worker node. First of all, I have cluster. Inside cluster, what I have? Nodes. Inside node, what I have? Pods. What I have, sir? Pods. Inside pod, what I have means container. What I have? In this pod. Like actually we create containers, right? But in containers, we are going to place on pods here. Where is the container going to place here? Pods. Inside pod, we have container. Inside container, we have. It is a thing. First of all, we have cluster. Inside cluster, what we have? Nodes. Inside nodes, what we have? Pods. Inside pod, we have. Inside container, we have. You will get some clarity, but that clarity is only 30% of clarity. I'll give you more advanced clarity now. Let me open one more document for you. You know onion, right? Onion. Onion layers will be there, right? OSA model. Know about it? How many layers we have on OSA? What are those? Okay. Okay. Architecture లేదా అసలు. Okay. Then I'll tell shortcut for that as well. Don't worry. If you see here, sir, it is normal architecture. First of all, we have cluster. What we have? Inside cluster, are we having master node and worker node, sir? Master node and worker nodes. Inside worker node, what we are having? Pod. Inside pod, what we are having? Container. Inside container, what we'll have? In Docker, some we have seen up to container and application. You know container. Inside container, what you will have? That part you know on Docker. Correct or not? And after that, I have implemented the cluster. In Docker, so have we create cluster or not? In Docker, so we create cluster. Inside cluster, we have nodes or not, sir? Inside node, what we'll have? Containers. Inside containers, what we'll have? Then what is the new thing adding? Means here pod only adding compared to Docker Swarm and Kubernetes. Docker Swarm also cluster. Kubernetes also cluster. In Docker Swarm also we have master and worker nodes. Kubernetes are also having master and worker nodes. In Docker Swarm as well we have containers. Kubernetes are also having containers. In Docker Swarm we have application. Kubernetes also application. But what is different? Kubernetes we have pods. What will have? So what is the meaning of pod? Pod means group of containers. What we are going to call it as? Right. Pod means group of containers. Pod means what, sir? Group of containers. So now if you see this is architecture number 1. No. So first of all, it is architecture number 1. It is difficult. But when you compare this architecture with this one, is it better or not, sir? No. Now compare architecture 2 with architecture 3. First of all, we have inside cluster, inside node, inside pod, inside container. Now are they having clarity? First one is very difficult. Second one is better. Third one is more better. Then what is the best one now? I'll tell the best method now. All of you know about the heroes, right? Let's take one family. I'll take one family and I'll try to explain. Okay. For example, let's consider this family. 1 second, let me open Paint. So if you watch Telugu movies, Kubernetes is very easy for you. Really. If you watch Telugu movies, Kubernetes is very easy. I'll tell you. Sir, first of all, let's take one family. Chiranjeevi family. First of all, we have Chiranjeevi, right? After Chiranjeevi, we have Nagababu. After Nagababu, Pawan Kalyan. After Pawan Kalyan, Ram Charan. And after that, the big hero is Allu Arjun, right? So if we go and see here, C for what, sir? Cluster. And N for node. And P for what, sir? Pod. And again C for container. And again A for application. That's it. So what we have? Chiranjeevi, Nagababu, Pawan Kalyan, Ram Charan and Allu Arjun. Easy or not, sir? It is the best one now. Huh? Easy again. Okay. So now, like normally when you try to understand, it cannot able to understand. But with the help of these kind of shortcuts, are you able to understand or not, sir? Shortcut number 1. I'll tell you shortcut number 2 as well. Do you watch Raviteja movies? What is the famous dialogue of Raviteja? Huh? That director, correct. Tell me a dialogue. Chandigarh local, okay. What the dialogue is? Assistant Commissioner of Police will come and go. Chandigarh will not change. ACP will come and go. Chandigarh C will not change. Again come here, okay. And C. Again if you go now bottom to top, C for what, sir? Cluster. Again N for node. Again P for what? Pod. Again C for container. Again A for application or not. Again A for what? Application. I have explained 2 examples. Use what you remember. గుర్తుంటే ఇక్కడ వాడుకోండి, పడికొస్తే ఎక్కడన్నా వాడుకోండి. Okay, so these are the 2 examples. If you talk about these 2 examples, you can remember on any way. I'll prefer the first one. Why? Because everyone see movies since our childhood, right? Of course, you can't able to understand. If you can't able to understand, try to remember these things. In interview, they will ask you, tell me the architecture. How can you tell? You don't know, right? You don't know. Then what you need to do? At least try to search for some alternatives. It is the alternative. So again, tell me the architecture. Now real architecture. First of all, we have cluster. Inside cluster, what will have? Nodes. Inside node, pod. Inside pod, inside container, application. Is the point clear for all of you? That's it. Write this one. Write this one. And at the end, write this one first of all. Okay, so architecture start with cluster. Inside cluster we have nodes. Inside node what we have? Inside pod. Container. Inside container, what is the shortcut? Like whatever it can be. Solon, what about you? Are you able to understand, guys? I'm not getting any response from you. Okay. So now you know the architecture. So inside the architecture, we need to work now. What we need to do? Have you read this one? In the bracket, write node point, note. Note. Said by Raham sir. Invented by, sorry. Invented. Because I was the one who invented this, okay? It's on my name only. I'll take the patent rights for it. Okay. Write that one, right? In future, if someone take your notes, okay, this is the best one. Who said this one, Ram sir? I need to be popular or not? Write this one. Promote me. Okay. Jokes apart now. Sir, is the structure clear now? How the Kubernetes is going to organize the things? Okay. So now that's it, sir. And one more thing. Just give me 1 second. So now you know about the architecture, right? So now inside the architecture, we are going to working about the components. What we are going to know about now? Components. First of all, we are having cluster. Inside cluster, we are having master node and worker nodes. Inside node, what we are having, sir? pods. Inside pod, what we are having? Containers. Inside container, concept clear now? Now here, cluster is a group of servers. We already said this one. I said on Ansible, I said on Docker, and again I am telling on Kubernetes. Cluster is a group of servers. It will have both master node and worker node. Cluster is having both master and worker nodes. Okay. Master node is assigned task to the worker node. Same Docker Swarm concept or not, sir? Worker node will perform the task. Okay. Same Docker Swarm concept. Docker manager will give work to the worker node. Here also, master node will give worker to the worker node. So next we are going to discuss about components. In master server, we are having 4 components. How many components, sir? First of all, API server. Second one, HCD cluster. Third one, control manager and scheduler. These are 4 components of master. How many components are there, sir? For master. And again for worker node, we are having how many components, sir? 4. For worker, no, like actually 3, but 4th one is optional. Okay. That's it. Next. So in worker node, kubelet, kubeproxy, and pod. Don't write container. Why? Because container is already inside the pod only. Master node 4 components, worker node also 4 components. Master node, API server, etcd, control manager and scheduler. Worker node, kubelet, kubeproxy, pod and container. Is the structure clear for you now? And if you go to here, sir, it is my master node. What it is? Inside master, API is there, etcd is there, controller and scheduler. Is it clear now? And again on worker nodes, kubelet, kubeproxy, pod. Like this. So now I'll discuss about one by one. First of all, we are going to learn about API server. What we are going to learn about? API server means, for example, if I want to run command, in Docker, we have Docker client, right? In Kubernetes, whenever I want to run the command is going to send to the API server. For example, see, if I'm a DevOps engineer, if I give kubectl run pod, this command is going to send to which server, guys? API server. API server will take the command from the user, execute the command, and give output to the user. Is the point clear? API server is to communicate with the user. It will take the input from the user. It will execute the command. Whatever output you got, it is going to show to the user. Simply one word answer is to accept the request from the user and store the requests on etcd. etcd is nothing but database actually. Okay. etcd means it is like database of our Kubernetes. For example, in my Kubernetes, I have 100 containers. How many containers? This 100 containers information is going to store on etcd. 100 containers information are going to store on etcd. Okay. API server communicate with user. It will take the command, it will execute the output and gives it to the user. 2 points. API server takes the command, execute the command, give it to the user. First one. Second one is API server is it for communication purpose. Which purpose? Write these 2 points. API server use it to communicate with user. First point. Use it to communicate with the user. It will take the command from the user, execute the command and gives the output. Is the concept clear now? That's it. So second one, etcd. What is the meaning of etcd? Means etcd is a database for our Kubernetes cluster. etcd means database of our Kubernetes cluster. That means if I have 100 containers, all the containers information are going to store on etcd. So etcd will store the data on key value format. Which format? Key value means which one? AML. Obviously. AML works on which one? Key value pair. Write this point. etcd will store the information on key value pair. etcd will store the information on key value pair. And the key value pair information is going to an AML format. You know it, right? That's it. Next, the third one is scheduler. What is the third one, sir, here? What is the meaning of scheduler? Means, for example, if I want to create one pod, that pod is going to scheduled by scheduler. For example, tell me one thing. It is my main node. It is the worker node 1. It is the worker node 2. I want to create a pod. I give the command to API server. API server will execute the command or not? Whenever API server execute the command, how many worker nodes I have, sir? 2 worker nodes. How many pods I am creating? 1 pod. Now I create 1 pod. This 1 pod need to go for worker node 1 or worker node 2. That is going to decide by API server. Sorry, scheduler. Which one? If I create a pod, that pod is going to schedule on worker node. That scheduling is decided by the scheduler. Okay. It is used to search for the pending tasks which are present on etcd. If any task is pending on etcd, it will schedule on worker node. Scheduler is going to schedule the works on worker node. It will decide in which worker node our task should be executed. I said right, we are having multiple worker nodes. The pod need to be created on which worker node decided by the scheduler. Who is going to decide it? Sir, how scheduler is going to decide? For example, I have 2 worker nodes. I have 1 pod to create. Then how kube scheduler is going to select the perfect node? How? Can anyone tell me? How it will schedule it? Do you have any idea? Just try to tell the answer. I'll correct if it is wrong. Okay, sorry. Let me tell you one thing. For example, you have 2 demos. One is a demo given by person A, one is a demo given by person B. 2 are DevOps demos only. You attend for both demos. How can you select the best one? Depends upon the quality of teaching, the content, and the way of explanation. Correct or not? That means you are checking the skills of the person. Correct or not? Here also same thing. When I have 2 worker nodes, first of all, kube scheduler will check the hardware properties of server number 1 and hardware properties of server number 2. When it checked the hardware properties of both servers, if it found the server number 1 is good, this pod is going to schedule on server number 1. If the hardware properties of server number 2 is good, the pod is going to schedule on server number 2. So scheduling the pod is always going to depend upon the hardware properties of the server. For example, server 1 have 10 CPUs, server 2 have 5 CPUs. Which one is better, sir? Server number 1. It will schedule on server number 1. Again, server number will have 20 GB of memory. Server number 2 will have 2 GB of memory. Which one is better now? It is going to schedule the pod on server number 1. So depending upon the hardware configuration or hardware properties. Who is going to schedule the pod? Scheduler is going to schedule the pod. How scheduler will schedule the pod depends upon the server configuration. Point clear? That's it. And last one is controller. So what is the last one, sir? What is the meaning of control? Means it is used to perform an operation which is scheduled by the scheduler. For example, scheduler give one work. I mean, scheduler work is to schedule the pods only. They schedule only pods. So controller main operation is to control the things. For example, it will control the service. We have service controllers, we have network controllers, and some other controls as well. Okay. So basically, controllers are 2 types, guys. First one is 2 types. First one is Cloud Control Manager, CCM, Cloud Control Manager, and second one is Kube Control Manager, KCM. How many controllers we have? First one is CCM. CCM means what? Cloud Control Manager. Second one is Cloud Control Manager means if we are implementing Kubernetes on cloud, it is Cloud Control Manager. If you are implementing Kubernetes on cloud, it is going to call as Cloud Control Manager. But if you are implementing Kubernetes on non-cloud, that is going to call as Kube Control Manager. Which control manager? At this point. If you are implementing Kubernetes on cloud, we are going to work with Cloud Control Manager. If you are implementing Kubernetes on cloud, it is called as cloud control manager. If you are implementing Kubernetes on non-cloud, that is called as kube control manager. Which one? Write that one. So that's it. API server is done, etcd is done, scheduler is done, controls are also done. So what is the API servers are used for communication purpose. If you give the input will be executed, you will get the output. Second one is etcd. What is the second one? Etcd means what, sir? It is database for our Kubernetes cluster. It will store the Kubernetes information. Third one is scheduler. What is the work of scheduler? To schedule the pods. How it will schedule the pods? Based upon properties. Fourth one is controllers. Controller means Kubernetes, like it will control the things. If it is implementing on cloud, cloud control manager. If it is implementing on non-cloud, kube control manager. It is components of master node. Which node? Are you seeing this one? API server, etcd, controller, and scheduler. Are you seeing this one? Master node. Now second is worker node components. Which node components? Kubelet, kube proxy, pods. First of all, I'll tell about kubelet. Kubelet is nothing but an agent. Kubelet is what? For example, if I create a pod on worker node, if the pod is running, it is going to check. If the pod is running, it's okay. If the pod is not running, it will intimate to master. It will intimate to master. Okay. Kubernetes work is to schedule the pods. If you schedule the pod, the kubelet is going to check the pod is running, not running, deleted, distracted. Or crashed, what happened? Whatever event happened to the pod, that is going to taken care by the kubelet. Kubelet is going to monitor the pods actually. If container is stopped or deleted or created, it is going to intimate to master. Who is going to intimate? Kubelet is going to intimate to whom? Master. How it will intimate? With the help of APIs only. Second one is kube proxy. Second one is what? Proxy means completely your networking concept. Which concept? Proxy means what? Like instead of you, some other will attend normally. So containers are going to create in a network. That network is going to manage by kube proxy. How it is going to manage? Kube proxy. So third one is pod. I already said what is the meaning of pod, guys? Group of one or more containers. Fourth one is container. What is the meaning of container? We already said container is an operate a VM which does not have any kind of operating system. Give me 1 second. Okay. So now again, kubelet is going to be agent which is going to inform everything to master. Qproxy is communication purpose, networking actually. So not communication, networking purpose. Pod is nothing but group of containers. And what is the meaning? Meaning of container, we know already what is meaning of container. So these 8 together we are going to call it as components of master node and worker node. Is it clear? So these are going to call it as components of master and worker nodes. Now one more time, all components. I'll explain here. Sir, API server main purpose is to communicate, take input from the user, execute and gives output. And next, etcd purpose is to database of Kubernetes components. And next one, scheduler main purpose is to schedule the pods. And control manager main purpose is to control the things like service controller, network controller, volume control. We have a lot of things like that. And after worker node, kubelet main purpose is to, it's an agent, it will monitor the pod condition, running, started, restarted, deleted, like that. Next, Qproxy means networking component. Pod means group of containers. Inside container, inside pod, what we have? Sir, this container is going to create by container engine. Basically, some people will call it as container engine. Container engine is nothing but the engine which create container, like simply called as Docker. Container engine means what here? Docker, like that. Is it clear now? So these are called as your master and worker node components. Sir, now if I want to set up Kubernetes, theoretical part, now you know the architecture. Next thing we are going to set up. Sir, if you want to set up Kubernetes, we have a lot of things. Not one or two, like we are having multiple things. For example, first one, we can use Minikube actually. Minikube is self-managed Kubernetes cluster actually. Not only Minikube, self-managed Kubernetes cluster means only Kubernetes will work here. We need to create our Kubernetes. Only we need to create. First of all, Minikube. Minikube is a single node cluster. Minikube is what? Second one is Kubedium. Kubedium is multi-node cluster. Third one is COPS. What we are going to call it as? COPS is also a multi-node cluster. Sir, Kubedium is multi-node cluster, COPS also multi-node cluster. But what is the difference? Means Kubedium is the manual way of creating servers. Kubedium is manual way, but COPS is automation way. Which way? So again, self-managed Kubernetes clusters are Minikube, Kubedium, and COPS. We are going to call it as KOPS also. What we are going to call it as? KOPS. So Minikube is a single node cluster. Minikube is what here? Single node cluster. Second one is Kubedium. Kubedium is multi-node cluster. Third one is COPS. KOPS also multi-node cluster. But what is the difference between Kubedium and COPS, sir? Kubedium is manual way. COPS is, that means COPS will create your servers. It will create your VPC. It will create your load balancer. It will create auto scaling group. Everything it is going to create automatically. It is self-managed. But sir, cloud clusters are also there. That is called as managed Kubernetes, like cloud control. These are what called as. For example, see, if we want to implement Kubernetes on AWS, we have AWS EKS. What we are having? But if we want to implement Kubernetes on Azure, we have AKS, Azure Kubernetes Service. In GKS, we have Google Kubernetes Service. Like this entire end-to-end we need to manage, but these are going to manage by the cloud providers. Is it clear now? So we can manage our own Kubernetes cluster or we can take support from the cloud as well. Okay. That's it. So depend guys, some organization will use self-managed, some organization will use cloud manager like. Okay. So here we are going to learn about self-managed clusters. So now, sir, why we are, so sir, you tell this much of things, right? Docker Swarm is able to help for us, but why we are not using Docker Swarm means, first of all, set up Docker Swarm is very easy. but Kubernetes is complex. But Docker Swarm is not having auto scaling. In Kubernetes, we are having auto scaling or not, sir? Community. We don't have community for Docker Swarm actually when compared to Kubernetes. Kubernetes having good community. Okay. And GUI. Basically, Docker Swarm will not have GUI. Of course, we are using Portainer, but Portainer is third-party application or not? Portainer is not our inbuilt Docker application for monitor. Okay, Portainer is third-party application. But Kubernetes, we have inbuilt dashboards. Docker will now never have inbuilt dashboard, but Kubernetes have inbuilt dashboards. Is the concept clear now? That's it. Okay. So now, first of all, I'm going to explain about Minikube. What's the time now? Okay, Minikube. So I'll tell the setup of Minikube and we'll end setup for today. Sir, basically Minikube is a tool used for single node cluster. Minikube is going to use for, that means we don't have one master and one worker node. We have only one single node. That is the master, that is the worker node. Okay. It contains API server, etcd, container runtime, everything it will contain. Why? Because it don't have worker nodes. It don't have worker nodes. If I don't have worker nodes, what is the purpose of using scheduler? Scheduler is to schedule the person worker nodes. I don't have worker nodes. How come I have schedulers here? Even though if I have, I don't have use with it. Like that. It helps you to containerize your application. We can containerize our application and it is used for developing and testing only. So Minikube we can use for Kubernetes, but only on dev and test environments. Which environments? We cannot use Minikube on real-time production environments. Note this point. Minikube can be able to use for only. Note. Minikube can be able to use only for dev and test environments. Which environment? Dev and test. But for production, can we use Minikube, sir? We can't. So next it is platform independent. What is the meaning of platform independent? Platform independent means it can run anywhere. And we have master and worker nodes on same machine. I already said Kubernetes is cluster. Cluster means master node and worker nodes both are different. But on Minikube we have on the same panel. By default it will create only one node. I already said Kubernetes is single node cluster. How many node cluster? Single node means how many nodes will come, sir? One node. Here I said Kubernetes is single node cluster. Single node means only one node. In one node, it is master, it is worker. Both are same. Next, installing Minikube is very simple when compared to other tools. Okay. Note point, I said, but we don't implement this Minikube on real time. Of course, we implement on dev and test environments. But for production, we do not implement Minikube. Okay, like that. So if I want to do setup for Minikube, first of all, I need to have two CPUs. And I need to have 2 GB of RAM. Memory means RAM here, and 20 GB of EBS volume. And internet connection I need to have, as well as Docker I need to install. Without these prerequisites, we cannot set up the Minikube. The concept clear? First one, requirement 2 CPUs we are having, and how much of RAM we are having, and how much of disk space we are having? 20. And internet connection is must, and we need to have one Docker install. So now to set up the Minikube, here we are going to follow this one. Minikube setup is this one. Okay. So I'm going to install some script based. Guys, here we are having totally 4 steps. How many steps? Step number 1 is updating the server. Step number 2 is installing the Docker. Step number 3 is installing Minikube. Step number 4 is installing kubectl. Okay. Docker we need to install. Minikube we need to install. Kubectl we need to install. Sir, you know how to why to install Docker? Why to install Docker? To get containers. And why to install Minikube? To orchestrate container. But why we need to install kubectl means the best thing about Kubernetes is if you want to work with Git, you need to install Git or not, sir? If I want to install Ansible, I want to work with Ansible, what I need to install? If I want to install Docker, I want to work with Docker, what I need to install? But if I want to work with Kubernetes, I don't install Kubernetes. Point clear? I'll work on Kubernetes only, but I will not install Kubernetes. For that purpose, I need to use kubectl. What I need to use? Kubectl is command line tool for the Kubernetes, right? Kubectl is command line tool for Kubernetes, used to execute the Kubernetes commands. Kubectl is command line tool for Kubernetes, which is used to execute commands on Kubernetes cluster, which is used to execute commands on Kubernetes cluster. Is the point clear for all of you? So now to install Minikube, I'll give one script. You also follow the same script. Okay. A script like I have on local, but before do this, click on instances. So now to install Minikube, I'll give one script. You also follow the same script. Okay. A script like I have on local, but before do this, click on instances, click on launch instance. In the launch instance, take Ubuntu this time. What I am taking? Ubuntu. And Ubuntu also I am taking 20 version. Remember, in practice, what you will do is you will directly create AWS Amazon Linux and you will execute that command. That command will not come. Why? Because here I am using Ubuntu. What I am using? And Ubuntu also I am using 20th version. Which version? 20th. Sir, I want 2 CPUs and 2 GB of RAM. T2 micro is capable of 1 CPU and 1 GB of RAM only. That means I need to use at least T2 medium. Sir, is T2 medium having 2 CPUs, sir? And more than 2 GB of RAM, sir? That's it. Key pair, select one normal key pair. And security, give all traffic definitely. Of course, it is not free tier, but we need to use. And what is the minimum EBS volume we need to use? 20 GB, but take 30 GB. Up to 30 GB is free, right? Take 30 GB is fine. Now you create one server. Mobaxtown. Let me open this one. So this Minikube is creating now. Sir, local I have some script. Okay, local I have some script. I am going to use this script only. Okay. Why? Because if we execute manually, it will take a lot of time. It is the script, copy the script and execute. Okay. So you know how to execute script, right? First of all, connect to the Mobaxtown. So now your Ubuntu is fine now. Are you seeing your Ubuntu here? So go to the root user, sudo -i, and create one separate file while separate directory. Why? Because in root folder for Ubuntu, we have a lot of default things. Okay, don't mess up with this. Create a folder mkdir Folder name can be anything. I am giving ABCD. Okay. Go to ABCD and install everything here. Why? Because guys, Ubuntu will come with some default files, hidden files. Okay. So create some separate folder for your clarity. VIM, I am giving minikube.sh. You are seeing the script here, right? Copy the script, directly copy it. Okay. Don't do anything. Now this script is going to execute automatically. Your setup will be done on 5 minutes. Wait for a couple of minutes at least. It will take some time. Wait for it. Okay. What? Any doubt? So it is checking for CPU limits. Do you have 2 CPUs, sir? As well as do you have more than 2 GB of RAM, sir? It will check. If checks is password, then it will start the minikube. Otherwise, it won't start. So what is the version of Kubernetes here? 1.26. And what is the version of Docker here? 23. So now it is starting. Yeah. So if you see, done. Kubectl is now configured and to use minikube. And cluster and default namespace. Okay, I'll tell you about what is the meaning of namespace. It is not the concept, no. So now your Kubernetes is completely started, sir. Your Kubernetes is completely started. Now you have the cluster. You have the cluster. Inside cluster, you have master and worker node. Master and worker here both are same or not. Now here what you need to create? Pods you need to create. What you need to create? We talk about architecture. Cluster we have. Inside node we have. Now we need to create what, sir? Inside pod what we will create? This part we will see now. So to create the pod actually we have 2 ways. How many ways, guys? 2 ways. Let me take this one. I'll give it on history comments. Pod can be created. First of all, what is the meaning of pod? Pod means group of. Pod means group of containers. Okay. It is the smallest unit of Kubernetes. Smallest unit of Kubernetes. Pod is the smallest unit of Kubernetes which can be deployable. Pod is the smallest unit of Kubernetes which can be deployable. I mean, we cannot deploy containers here. There is no possible to deploy containers. We can only deploy pods. What we can deploy only? Inside pod, we have containers. What we will have, sir? Inside pod, we have container. Inside container, what we have again? Application. Then again inside container, we have application. Is it clear now? Okay. Sir, then if I want to create pod, I can create on two ways. Pod can be created two ways. How many ways? First one is imperative. What it is? Imperative means create pod by commands. Write this one up to. Just write the way, imperative first. What is the first way here? Imperative. Second way is declarative. Second one is what here? Declarative. Declarative means create pod by manifest file. Which one? Manifest file. Sir, if I want to create pod, how many ways do I have, sir? Two ways. What are those? Imperative and declarative. Imperative means creating by using commands. Simply like write this one. By commands, and declarative means create pod by using manifest file. Is it clear now? First of all, I'll tell about imperative way. Imperative way means creating a pod by using command, right? Sir, I need to give the command like this. The command is kubectl run. What is the command to run a Docker container? Docker run container name. Here also kubectl run pod name I need to give. What I need to give? My pod name is pod1. What is my pod name? Sir, inside pod, you are going to create container. For that container, we need to give image name or not, sir? Hyphen image is equal to, I am going to take Nginx image. Which image? Or you can take our own images like Raham Sheikh. What is the image name we are having? What is the image name it is? Like tell me any one image name. Naresh IT, like we have something AWS, repo, NIT, latest. Is the pod created, sir? Write this command, complete command. So kubectl pod 1. What is the pod 1 here? So kubectl run. Kubectl is a command line tool, and run, you are doing work here. And what is the name of the pod, guys, here? Pod 1. For pod 1, what is the image I am giving? Ramshek AWS reparent. Of course, you can give whatever image you want. You can use Jenkins image, you can use Nginx image, you can use Apache image, whatever image you can use. It is imperative way. Which way? Imperative. For example, I want to get the information about the pod. The command is kubectl get pods. Are you getting pod information? What is the command I have given? Kubectl get pods. That means I am getting pod information. What is the name of the pod? Pod 1. I have one pod is ready, and status of the pod is running. Have I restart the pod? No. And what is the age of the pod 78 seconds ago? Of course, you can give the same command with POD. Same output. And again give up arrow. You can give PO. All are same or not, sir? You can give PODS, or you can give pod, or you can give PO. Write these three. So what is the command to get information about pod? Kubectl get pod. Kubectl get pod or pods or PO. Okay. Okay, so now here, what exactly I'm going to do is, sir, kubectl run pod 1, I have given, right? So I have given the kubectl run pod 1 and image. So now one pod is created. How to check the pod information? Kubectl get pod. But if I want to get more information, I can give kubectl get pod -o wide. -o wide will give somewhat of other information. Right, command number 2. Kubectl get pod -o wide. -o wide will give some additional information. It will give some additional information. Is it clear now? And third one, if I want to get complete end-to-end information, command is kubectl describe. What it is? Sir, in containers, we use inspect command. Which command? Here, describe command. Kubectl describe pod. I am going to describe the pod. What is the name of the pod? Pod 1. Now it will give me the complete information. Oh, 1 second. Kubectl CRIB. Here you have this. If you do some errors, Kubernetes will tell you. I gave the error, but it is telling, do you mean describe? Yes, I mean it only. Now am I getting complete information or not, sir? So here if you see, this is pod 1, namespace is default. It is running on Minikube. Minikube IP address is this one. And we have label is equal to pod 1. Complete end-to-end information is coming or not, sir? That's it. Okay. What is the command to get end-to-end information of a pod? Kubectl describe. It will give the complete information of a pod. Is the command clear for you? It is the first way. And sir, for example, if I want to delete the pod, kubectl delete pod. What is the pod name? Pod 1. Is the pod 1 gone? It is what you are going to call it as deleting of the pod. By imperative method, which one? Imperative method means what here? By using command. By using what? Command. So second one is declarative method, sir. Second one is what here? Declarative method means by using manifest file. Which file? What is the meaning of manifest file is, sir, whatever the pod you create from the CLI, you are going to create it from the manifest file. What is the meaning of manifest file? Means here we are going to run the manifest file on YAML. For example, say I'll create one file vim pod1.yml. I am giving the name like this. So it is start with API version. In API version, V is capital. API version is V1. For pod, we need to give API version as V1. And after that, what is the kind of object I am creating? I am creating pod here. What I am creating? API version for pod is V1. You know what is the meaning of API version? Already we have seen on Docker. Their version here, API version. Kind means kind of object. What I am creating, sir, here? Pod. And next, metadata. Metadata means data about pod. For example, I want to give the name of the pod. What I want to give? Name of the pod. 1 second. Let me give it properly. So I'm giving metadata. So metadata, I'm going to give it as name. What is the name of the pod? Means pod1 only. What is the name of the pod? Pod1. After that, I need to give spec. What I need to give? Spec means specification. Spec means what here? Specification. I am going to create containers. What I am going to create? What is the name of the container I want to create? I need to give some name, right? So if you go here, I have already given this one. Yeah, here. In spec, what I am giving, sir? Containers. So I am giving it as containers. 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 For a container, we need to give image or not, sir? Hyphen image. What is the image system? I am taking Nginx. What I am taking? Nginx is fine. And after that, we need to give name of the container as well. So name of the container is container1. What is the name of the container? Of course, this is not figured properly. If we want to figure it properly, in YAML I said one thing. Have I said you about YAML lint? YAML lint is to validate the YAML syntax. Their syntax is not coming properly, but here I can modify it or not, sir. Copy it here and click on go. Am I getting perfectly or not? Copy this. Because sometimes manifest file or like normal files, this one, it won't come with proper indentation. So delete, just give 100 DD, lines will delete it and paste it now. Is it coming properly or not? First of all, API version is V1. And what kind of object I am creating? Pod. And what is the metadata here? Name of the pod is pod1 only. Specification means I am giving about container information. What is the image for container? Of course, you can take Raham Sheikh AWS repo and latest as well. And image I am going to take it as Nginx. And name of the container is container1. Save it now. Sir, if I want to create pod from the manifest file, the command is kubectl create. What I am creating? Create -f for file. -f for what is the file name? Pod1. Is the container created? Kubectl get pivo. Same output or not, sir, here? Same output. Again, kubectl describe pod1. Kubectl describe pod1. Again, same output is coming or not, sir? Same pod, but how many ways I have created? 2 ways. First one is imperative. Second one is imperative means by creating comments. Declarative means by creating manifest. What is the command to list the pods? Kubectl get pod. And what is the command to delete the pod? Delete. What is the command to get the full information of a pod? Describe. Sir, for example, if you open the manifest file, cat pod1.yml, in the manifest file, here you mention V1. You mention, why you mention V1? First of all, because in Kubernetes, by default, we have some API resources. What we have? According to that only we need to mention. I'll tell you, just to give the command kubectl API-resources. If I give kubectl API resources, search for the pod here. If you see, are you seeing the pods here? Sir, for pod, what is the shortcut, sir? Shortcut name is pivo. And what is the API version? Have I given that or not, sir? Huh? What it is? 1 point. I'm not asking about Kubernetes version. You are telling about Kubernetes version. I am asking what is the shortcut for pod? PO. If I give the command kubectl will get PO. Is output coming or not, sir? And what is the API version of the pod? For that purpose, I put V1 here. Is it clear? That's it for now. So this is enough for today's class. So now on the class, any doubts or any queries from your end? Sorry? Master file. It's not master and worker. It is manifest file. Okay. Okay. I'll tell you about manifest file one more time. Cat. What is manifest file name? Pod 1. Here API version. For pod, what is the API version, sir? Just now I said, right? What is the kind of object you are creating? Metadata means data about pod. What is the name of the pod I am giving? Is it clear? First 4 steps. API version is V1. And kind what you are creating? Pod. And metadata what you are giving, sir, name of the pod. What is the name of the pod? To create a pod, you need to have container. Container information I am giving on specification. Where I am giving on? What is the image of the container? And what is the name of the container? That's it. The stuff clear now? So on today's class, what we have done is we have set up the Minikube. What we have set up? After Minikube setup, we have created the pods. Are these both steps clear for all of you now? 1 second, let me give history comment first of all. This is the history comment, and I'm also going to give the stuff for you. Setup. So Minikube setup I have already given. Let me paste this on your Google Classroom. It is day 1 of Kubernetes, right? How much of Kubernetes you want to learn? Huh? అది అవదమ్మా అది అవదు. Why? Because Kubernetes no one will learn completely, even I also. You know how much of Kubernetes I know? I know the vast part of Kubernetes, but it is only 10 to 20% of Kubernetes. I know very vast part, but it is only 10 to 20%. Kubernetes is very big ocean actually. If you keep DevOps, complete DevOps tools one side, and if you keep Kubernetes on one side, Kubernetes is very, very weightage. Okay. So that's the thing you need to understand. First thing you need to keep your mind is we cannot learn Kubernetes fully. You can learn Jenkins fully. You can learn Ansible fully, but you cannot learn Kubernetes fully. Okay. But I'll cover maximum part of Kubernetes. Okay. Create a new file. It is Kubernetes, right? So I'm giving, it is which tool for 7, right? Not K8s, and it is day 1, right? Day 1. That's it. So now any doubts or any queries from your end? Online guys, any doubts or queries from your end? If you don't have any doubts or any queries, we can session.